How are you, my friends? This is lecture number 35 of the pre-calculus course, Determinants of Matrices. You can see the other lectures, please, in this playlist down here. The objectives in this lecture will be, what is a determinant? Determinant of a 2 by 2 matrix. We will define minors and cofactors. Then we will find the determinant of n by n matrix, square matrix. What is a determinant? Determinant is a real number associated with each square matrix. When we say a real number, it can be positive number, negative number, zero, fraction, whatever. For example, the determinant of the matrix A here, so you look at A, 9, 10, 4, minus 5. The determinant is minus 85. I will show you how to get that. And if we have, let's say, 3 by 3 here, K, the determinant is 42. I will show you also how to find it. We can go also 4 by 4, 5 by 5, 6 by 6, etc. There is a nice formula to find the determinant of a 2 by 2 matrices. If we have a matrix A, B, C, D, the determinant, we write it as DET of A, or we write 2 bars of A, or we write 2 bars A, B, C, D. We multiply the main diagonal, AD, minus the product of the other diagonal. So AD minus BC. So we say determinant will be the product of the entries on the main diagonal minus the product of the entries on the other diagonal. So that will be a number there. Now let's see example 1. Find the determinant of each matrix E, F, and A. Just use the formula because this is 2 by 2. So you can check the numbers, please. You can check the answer if you like. Then you can see the next slide for the solution. Now, ready, I think you are now. See, E is square matrix 2 by 2. The determinant will be 2 times 5 over 4 minus 3 times 0, or 0 times minus 3. It's the same, so it will be 5 over 2. That's a positive number. This is F, 2, 1, 4, 2. Let's find the determinant. Determinant, we write 2 bars and then the matrix. It will be 2 times 2, 4, minus 1 times 4, so that will be 0. If the determinant is 0, we know there is no inverse for this matrix. Now let's look at A. Find the determinant. It's 9 times minus 5 minus 10 times 4. So that would be minus 45, minus 40, minus 85. You see the number here? The number I showed you at the beginning here, minus 85. See, this number here is the determinant. I found it in example number 1. Now, this is an important slide where we show the difference between the matrix and the determinant. It's very important. Note that the matrix is an array of numbers. So the matrix have square brackets. So this is the square brackets A, B, C, D. 4 numbers are there. Why the determinant is a single number. It's a real number with 2 vertical bars like this. So this is completely different. The down here is a number, and this is a matrix. Let's look at example 2. Solve the equation. We have the determinant of this 2 by 2 here, 2x minus square root of 7 here, tan inverse of 10 divided by 8 sine 5 pi over 6 is equal to square root of 28. We need the value of the x. That's an equation. Why it's an equation? Because we can simplify this on the left side. This is determinant. We find its value, we make it equal square root of 28, then we find x. You can try it yourself if you like. Now let's use the cancellation property for tangent. Tan inverse of 10 will be 10. That's a cancellation property. So this number here is 10. We find the reference angle of 5 pi over 6. So sine 5 pi over 6 will be plus, because 5 pi over 6 in quadrant 2, and the sign is positive, so that's a plus. Sine pi minus 5 pi over 6. This is the reference angle, which is pi over 6. Pi over 6 is 30, so sine will be half. Half times the 8 here, it will be 4 down. See, now we simplify the equation. We have determinant of this is equal to square root of 28. Let's apply the rule of the determinant 2 by 2. So we can multiply now 2x minus square root of 7 times 4. This one times 4, or 4 times that, that's to say, minus 10 square root of 7 is equal, square root of 28 would be 4 times 7. Take 2 out, 2 square root of 7. Just simplify, expand the linear equation here, and then multiply here by 4, 8 minus 4 square root of 7 minus 10 is equal to square root of 7. So 8x will be 16 square root of 7 divided by 8. X will be 2 square root of 7. Easy question. Now, before we start determinants of matrices with dimensions greater than 2 by 2, so we start 3 by 3, 4 by 4, 5 by 5, we need to use the idea of minors and cofactors. We will define these on the next slide. What is a minor? What is a cofactor? Now, if A is a square matrix for the entry Aij, see, if we have A is a square matrix, it can be 3 by 3, 2 by 2, 5 by 5, 6 by 6, whatever. And we have entries. The entries are the elements inside. Let's take Aij in some row and column. So the minor, capital M, the minor is capital M, Ij is the determinant of the matrix obtained by deleting the ith row and the jth column of A. I will explain that in an example. Now just let me say the cofactor, capital Cij, is given by the formula. Cofactor, capital Cij will be minus 1 to the power I plus j times capital Mij. So to find the cofactor, you have to find the minor. To find the minor, we have to delete. Deleting here, we cancel some rows and columns. Let me show you the example here. Find the minor and cofactor of the entry minus 2 in this matrix T. See, here we have 4, 7, 6, 3, 0, 10, 2 minus 2, 5. This matrix T is 3 by 3, right? So we have 9 elements, or we can call them 9 entries. Let's choose one of them, minus 2. I can choose 10, I can choose 7, I can choose 5, I can choose any. So in this example 3, we choose minus 2. We need the minor of minus 2. We need the cofactor of minus 2. Each entry, 6, 7, 4, 3, 5, each one has minor and cofactor, each one. So let's find the minor and the cofactor of minus 2. See, minus 2 here, where is minus 2? It is in row 3, column 2. So I have to delete row 3, column 2. This is the deletion. So minus 2 is located in the 3rd row and 2nd column. So the minor, capital M, 3, 2. From where I get 3, 2? This is Ij. 3, 2 from row 3, column 2. So I delete this. What's left? 4, 3, 6, 10. So to find the determinant here of 2 by 2, it will be 4 times 10, 40, minus 6 times 3. So the minor of minus 2 is 22. Again, please be careful here. The minor of minus 2 is a number. It's 22. Now let's find the cofactor of minus 2. Use the formula. See, to find the minor, delete row and column. To find the cofactor, use the formula. Minus 1 to the power 3 plus 2 times capital M, the minor of 3, 2, which we found already here, 22. So minus 1 to the power 5 is minus, because this number is odd. So the answer is minus 22. So minus 22 is the cofactor of minus 2. Now, example 4, we have a matrix A also 3 by 3. Let's find, this is like exam type. Let's find capital M 33 plus capital C 21. Can you do it, please? I think try. This one means the minor of the element in the location 33 plus capital C 21. We need the cofactor of the element in the location 21, row 2, column 1. In the first one, it's easy, delete. Second one, you have to find the minor first, then the cofactor. Try it, please. It will be one number in the answer. Let's see. This is A, M33, so this is M33. Third row, third column. So we look at minus 10 here. This is the element. So we delete row 3, column 3. What's left is 4, 5, 3, minus 2. So here, minus 8, minus 15. So capital M33 is the minor, which is minus 23. That's it. Now, let's continue and find C21. C21, where is C21? 2, second row, first column. Second row here is the 5. Second row, first column, C21. So what's left here is 3 minus 2, minus 2 minus 10. But you have to put the formula here, minus 1 to the power 2 plus 1. So minus 1 cubed times the minor of this 2, 1. That's only the minor here. And the minus 1 to the power 2 plus 1 is coming from the cofactor rule or cofactor formula, if you like. This is minus 30. And then minus 4, because this is the minus. This will be minus and minus. 3 minuses are there. So minus 30 minus 4 is minus 34. And there is a minus here, so it becomes 34. Now, what do we need? M33 plus capital C21 minus 23 plus 34 will be 11. Now, here we reach the main idea of this lecture, finding the determinants by cofactors for the square matrices 3 by 3 or more. So the determinant here of A is the sum of the products of the entries in any row or column of A and their respective cofactors. Maybe it's not clear here. I will read it again and then explain it with many examples. The determinant will be the sum of the products. So sum means we add things here. See, we add the sum of the products. We multiply things. So we add things. These things are the product of the entries in any row or column. That means we have to choose any row or column from the matrix. And then we find the respective cofactors. If we choose, let's say, row 1, we find the cofactors of all the entries in row 1. If we choose column 2, we find the cofactors of all the entries in column 2. So this is an example. If the first row is used or chosen, then the determinant of A will be A11 times C11. See, the entry times the cofactor, its cofactor. A12 times capital C12. So the element, the entry, the number times the cofactor. Inside the cofactor, you have to find the minor. So in the formula here, the minor is not shown until we finish the elements in the row or the column. Let's see, I think, a nice important example here. Find the determinant of K, 0, 2, 5, 3 minus 1, 2, 4, 0 minus 1. Okay. Let's choose any row or column first. Let's choose row 1. This is row 1, you see, 0, 2, 5. So row 1 has what? The elements in row 1, A11, A12, A13. We know that. So the determinant of the K will be A11 times capital C11 plus A12 times capital C12 plus A13 times capital C13. This is only to remind you of the formula of the cofactor. So we put here, oh, let me tell you, you choose the row or the column that has many zeros because it will be easier for you. So this is 0. You don't have to find the cofactor C11 because it will be multiplied by 0. A12 is 2. We write it here. A13 is 5. So what's left now? I have to find the cofactor C12, cofactor C13. On the next slide now, I need, this is 0 already, and this is 2, and this is 5. Cofactor C12. See, C12, what do I do? Row 1, column 2 here. So I cancel row 1, column 2. So what's left is 3, 4, 2 minus 1 there. And minus 1 to the power 1 plus 2 from the formula here of the cofactor. And that's the minor there. Now C13, 1, row 1, column 3. So what's left? 3, 4, minus 1, 0. And I put here minus 1 to the power 1 plus 3, which is 4. Minus 1 to the power 4 is plus 1. I think it's a good idea now you continue here until you find the determinant of the k. And then check the next slide for the final answer. So now 2, we write here 2. Minus 1 cubed is minus. This is a 2 by 2. So we multiply 3 times minus 1, minus 3, minus 8. And here 5, minus 1 to the power 4 is plus 1. This is 0 minus 4 plus 4. This is what? Minus 3 minus 8 is minus 11 times minus 2, so 22. And this is 5 times 4 altogether, so the determinant of k is 42. If you checked slide number 1 or 2, you will find the determinant of the k is 42. This is how to find it. Okay. Now, let me do this determinant by another way. Let me choose column 2. Same number, ck 0, 2, 5, 3 minus 1, 2, 4, 0 minus 1. See? I will choose now column 2 here. See, this is column 2. So I will expand it by column 2. Column 2 has what? A12, first row, second column. A22, A32. And each one I find the cofactor, C12, C22, C32. Now there's a 0 there. I don't find this cofactor C, capital C32, because that's a 0. So I only find capital C12, capital C22. You can find it, check the numbers, and then at the end, as expected, we should find 42, because the determinant is a unique number. Every matrix has only one determinant, real number. More practice here. Let's find the determinant of W. Please, you can pause the video now. Very good idea. Try it yourself. Find the determinant of W. I hope you will get the correct answer. So W is 3 by 3, 1, 4, minus 2, 3, 2, 0, minus 1, 4, 3. Let's find the determinant of W. Okay. Let me choose column 3. See, this is column 3, minus 2, 0, 3. I will say again, you can choose row 1, you can choose row 2, you can choose row 3. You can choose column 1, you can choose column 2, you can choose column 3. It's up to you completely. Choose the one that has more zeros, better. So this one, A13 times the cofactor C13. This one here, A23 times the cofactor C23. This one, A33 times the cofactor C33. The one in the middle I don't find, because this is 0, it will be multiplied by 0. Minus 2 is there, the element, and the 3 is there. Now I've applied the formula for the cofactor C13. It will be minus 1 to the power 1 plus 3 times the minor of 1, 3. The last one here, 3 times minus 1 to the power 6, 3 plus 3 times the minor 3, 3. Continue on the next slide. Now M1, 3. 1, 3, this is 1, 3. When you cancel, you get 3 minus 1, 2, 4. And 3, 3, when you cancel row 3, column 3, you are left with 1, 3, 4, 2. Simplify all the numbers, you will get the determinant minus 58. Now, this is lecture 35, determinants of matrices. At the end of lecture 36, coming after this, which we call it properties of determinants, methods, that will give you ideas to find the determinant in easy way. There are many properties there in lecture 36. Now, after I finish lecture 36, you will find all the exams questions to practice on both lectures 35 and 36. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture 35, and we are reaching the end of the course, which will be lecture number 40. I hope I can see you in another video with another topic. Thank you for listening.